Ever wondered how solar panels convert sunlight into electricity? These sleek, shiny squares are more than just a pretty face. They're integral players in our global energy game, harnessing the power of the sun, our most abundant and renewable source of energy. Imagine the same rays that warm your skin on a sunny day transformed into electricity to power your home. Intriguing, isn't it? So let's delve into how this fascinating process works. Welcome to our channel. Support us by subscribing, commenting, and liking. Let's go to the video. At the heart of every solar panel, you'll find something called a photovoltaic cell. These cells are the workhorses of solar panels, tirelessly converting sunlight into electricity. But what exactly are they? Photovoltaic cells, often shortened to PV cells, are small, square-shaped panels that look a bit like shiny blue or black squares. They're the building blocks of solar panels, fitting together like pieces of a puzzle to create the larger whole. At their core, PV cells are made up of two layers of a semiconductor material, usually silicon. Silicon is a great choice because it's abundant and has just the right electrical properties. The silicon in PV cells isn't pure, though. It's mixed with other elements to improve its photovoltaic properties, creating an electric field across the layers. Now that we know what makes up a solar panel, let's see how these photovoltaic cells actually work. So, how does a photovoltaic cell convert sunlight into electricity? Well, it all starts with a simple yet extraordinary process. When sunlight, composed of tiny packets of energy known as photons, hits the surface of the photovoltaic cell, something remarkable happens. The energy from these photons is absorbed by the cell, which is primarily made up of silicon, a semiconductive material. Now here's where things get a bit more technical. Silicon atoms are arranged in a tightly bound structure, and each silicon atom is usually connected to its neighbors by four strong bonds which keep the electrons in place, preventing them from moving freely. But when the energy from the sunlight hits these bonds, it provides just enough energy to knock an electron loose. This creates a kind of hole where the electron was. This hole can move around the silicon structure just like a loose electron can, and when many of these interactions happen simultaneously, many electrons get knocked loose, creating a stream of free-flowing electrons. This movement of electrons and holes is what we refer to as an electric current, and this phenomenon is what is known as the photovoltaic effect. But of course, for this current to be useful, it has to be directed. Thus, within the solar cell, there are electric fields that direct these loose electrons in a specific path, creating a flow of electricity. The stronger the sunlight, the more electrons get knocked loose, and the more electric current is produced. So imagine billions of these interactions happening at the same time, and you begin to grasp the tremendous potential of solar energy. With just a single hour of sunlight, we could theoretically power the entire world for a year. This, in essence, is the science behind solar energy conversion, a process as old as the universe itself, harnessed by mankind to power our modern world. And just like that, sunlight is converted into electricity. But how do we harness this electricity for use? Now we have electricity being generated, but how does it get from the solar panel to powering your home? Well, it's a fascinating journey, and it all begins with the type of current that a solar panel produces. You see, the electricity coming directly from a solar panel is known as direct current, or DC for short. This is a type of electricity where the flow of electric charge travels in one direction. However, the appliances in our homes and businesses use a different kind of current known as alternating current, or AC. In AC, the flow of electric charge periodically reverses direction. So how do we convert DC to AC? This is where a device called an inverter comes into play. An inverter is a power electronic device that changes DC into AC. Once the electricity has been converted to the right form, it's ready to be sent on its way to power up our lives. But how does it reach us? That's the job of the power grid. The power grid is an interconnected network for delivering electricity from producers to consumers. It consists of generating stations that produce electrical power, high voltage transmission lines that carry power from distant sources to demand centers, and distribution lines that connect individual customers. And that, my friends, is how sunlight becomes electricity, thanks to the marvel of solar panels.